Welcome back, students. Today we're going to learn about how to predict polarity using solubility. Okay, so we need to do a little quick vocab review. Some of these terms we've heard before, talked about, but just as a review. A solute is the substance that you have less of, and it's going to dissolve and break apart when it's added into an appropriate solvent. So if you look over here in the picture, this is your solute right here. So this is what you have less of, and it's going to dissolve when you put it into an appropriate solvent. What is a solvent then? A solvent is the substance that you have more of. Okay, so it's going to dissolve or break apart the solute. It's going to break apart the other substance. Okay, so what that will look like is you'll have your solute that enters into the system, and then that solute's going to get quote unquote broken apart, and it's going to spread out within and around in the solvent itself. All right. One thing that you'll just help you maybe remember that if you can't remember the vocab, this little picture here, the V kind of is like a little cup. And the solute can go inside of the solvent. So if that helps you, you can use that. Okay. So the next thing we have is a couple more terms. So applying that to action is something that's soluble is where the solute is going to dissolve or break apart when it's added to the solvent. Okay, so in this animation here, we have our solute. Maybe this is a salt crystal. Okay, and then it gets added to, in this case, water. The water molecules are going to go in here, and they're going to break apart the solute. Okay, so in this case, the little negative ions that are in that salt, the little chlorine ions, are attracted to the positive hydrogens of the water. Okay. And then conversely, the positive ions in the salt are attracted to the negative oxygens of the water. And it's going to break it apart. So when something's soluble and it's solid, if it's soluble, it's going to look like it disappears. Okay, so we've done this in class already where you take salt and you put it into water. It looks like it disappears. It dissolves because it is soluble. Salt is soluble in water. Liquids, so if you have two liquids and if they're soluble, it's just going to look like they mix together. Okay, so food coloring, for example, you put that into water. Food coloring is soluble in water, so it just kind of looks like it mixes together. All right. In this example, now the other word is insoluble. What's happening if something is insoluble? It's the opposite. Okay, substance will not dissolve or break apart when it's added into the solvent. So in this animation over here, this is showing what would look like if you have oil and water. You guys know that oil and water don't mix. Okay, so in this animation here, the little blue dots are representing the water, and the little red dots would be representing your little molecules of fat that are from the oil. And they do not mix together. They are insoluble. Why? Well, because in this case, the water is polar and the oil is nonpolar. Okay, so the water is really going to want to attract and stay together, and it's not going to be attracted at all to the nonpolar molecules. So as a result, they don't mix together. It's different than the image up here with the salt and the water, where the water was attracted to the ions of the salt. In this example, if something's insoluble, it's not going to mix together. Okay. If there's a solid, the solid's going to eventually mix or fall to the bottom. Okay. So if you put something solid into a liquid and it's insoluble, like sand is not soluble in water, you put sand in water and it all just settles down to the bottom. Now if you do the same thing with a liquid, okay, again, it's not going to mix. It's going to stay separate. By density, the less dense thing will go on top and the more dense thing will be on the bottom. And that's what we see happen with oil and water. All right. So predicting, how we can actually predict the bond type here using solubility. Here's your rule. Like dissolves like. Okay. So polar solvents can dissolve polar solutes. Okay. And we say that it's charged solutes because technically it's going to be things that are polar and then ionic. And ionic have a positive and negative end, so they are polar. So like dissolves like. If something's polar, it's going to dissolve polar solutes. And then the converse is true. Okay? Nonpolar solvents can dissolve nonpolar solutes. Okay? So if you have something that's nonpolar, it will be able to dissolve something that is also nonpolar. If you have a polar substance, like a polar solute, and you put it into a nonpolar solvent, they are not going to dissolve. It's going to be insoluble. Polar solutes are insoluble in nonpolar solute or solvents. Okay, so just remember, like dissolves like. That's what's going to end up going together. Now, common solvents that we'll see and we'll use in here, water is kind of the universal solvent for polar things, because the water molecule, as we've already talked about, has a bent shape. It's asymmetrical, therefore it's polar, and because it's polar, it's going to dissolve polar solutes. The one we'll use a lot in class here for nonpolar is hexane. If you look at the hexane is symmetrical. You can take a mirror image of itself. Okay, so it does not have a positive and negative end. It is nonpolar, therefore it's going to dissolve nonpolar substances. Okay, just a little cartoon for you to end on. If you guys have any questions, rewatch the video. Please come in and ask for help before school, after school, or go to Science Resource.